Welcome students. Today we will learn about lenses. What are the components of lenses and how lenses are and what are the types of lenses. Before going into the topic, please do subscribe for the channel. We have seen refraction at one curved surfaces. That means we have considered the medium and we have considered only single curved surface. So this we have considered, either it may be concave or convex. So what happens if we consider two curved surfaces? Is it clear? So when we consider two curved surfaces, how the refraction will take place? Let us see. So first, before going into this, we need to learn about lens. So what is a lens? So lens is a transparent material which has one or both the surfaces curved. That means, see, suppose generally this is a plain surface. Is it clear? So lens will have two surfaces, either one may be curved surface or one may be plain, or both may be curved surfaces. Clear everyone? So lens, what is the definition of lens? Lens is a transparent material which has one or both surfaces curved. So when the lens have a curved surfaces, then those are called as spherical lens. So we have various types of lenses. Now we will see what are the types of lenses. First, see, now I have said that lens has two surfaces. So those two may be either curved surfaces or one may be curved surfaces. Now I am taking one side I am taking a plain surface and one side I am taking a curved surface. So this is a convex lens. Okay. So now this lens has one plain surface and one curved surface, and this curved surface is in the shape of convex. So that's why this is called as plano convex. Is it clear? So lens has one plain surface and one curved surface, and this curved surface is convex in shape. That's why it is called as plano convex. And next I am taking one plain surface and a concave. So this is a curved surface and this is in the shape of a concave. So this is called as plano concave. Clear everyone about these two? So one is plano convex and another is plano concave. So plano convex and plano concave, what they have? One plain surface and one curved surface. So convex will have convex curved surface and concave will have concave curved surface. And next we will see, if both sides, that means if both the curved surfaces, if both are curved surface. See, now I am taking convex and also I am taking a convex. So here one side is convex curved shape and here it is also a curved shape. That means both surfaces are curved structures. So this is called as two convexes are there. That means one curved surface and another curved surface, and both are in the shape of convex. So that's why it is called as double convex. And also we can call it as biconvex. So if both surfaces are convex surfaces, then it is called as double convex or biconvex. Next we will see, if we consider both as concave surfaces. See, so one side is concave and another side is also a concave. So now both are concave surfaces. So this is called as double concave or biconcave. given? First we have considered one plane surface and one curved surfaces. So these two are the conditions. And in the next case we have considered the two curved surfaces. So these are the two lenses we got. Here we have mixed concave, convex. That means see here I have mixed both the surfaces with convex, and here also I have mixed both the surfaces with concave. So if I mix concave with convex, is it clear? See, now this is a convex, okay, and this is a concave. Is it clear? So this surface is a convex surface and this side it is a concave surface. Then it is called convexo-concave surface. That means it is called as convexo-concave lens. Here I have mixed convex with concave. Now this is convexo-concave. Now we will see concavo-convex. So this is a concave surface and this is a convex surface. See here one side is concave and another side is convex. So this type of lens is called as concavo-convex. Is it clear? These are the different types of lenses where either one side is curved surface or both the sides are curved surfaces. So in all these lenses, for us we will consider in this unit only biconvex and biconcave lenses. Why? Because we will consider this for simplification. And here these rays. So now we have known about the lenses. Now we will know what are the types of lenses and what are the behavior and what are the components of the lenses. So lenses, for example, you can see the contact lenses which you keep in your eyes. Is it clear? So that is nothing but a lens that will be having these shapes itself. Consider a biconvex lens. The thickness of the lens will be thinner at the edges and will be more at the middle. That means the thickness will be more in the center and it will be less at the edges. And if a lens has two surfaces bulging inwards, then it is called as a biconcave. Why it is called as a biconcave? Because here the two surfaces are concave in shape. Is it clear? For this lens, if we consider, the thickness will be more at the edges and thickness will be less at the center. That means if you touch, practically if you touch a lens and whether to know what type of lens it is. So if you touch in the middle, if it is thick, that is if it is bulging, then it is called as a biconvex. If the edges are more, that means if the thickness when compared with the middle part, if the thickness is more at the edges, then it is called as biconcave lens. Now we will see terminology related to this. See here two surfaces. Okay, two surfaces are nothing but part of a spheres. Is it clear? Now I will consider a convex biconvex lens. Is it clear? So see, two surfaces are there. One is this surface and another one is this surface. Now this will make a biconvex lens. So if I extend and draw this, then this will be a sphere and this part will also be a sphere. That means these two surfaces are part of two spheres. So then the geometric center, that means the center of one sphere is at this point and the center of this sphere will be at this point. That means all the rays coming and meeting. That means a lens has two centers. And here we are considering the thickness as negligible. That means for understanding we are considering the thickness of a lens is very small. Is it clear? And the geometric center of this lens is nothing but called as pole. That is geometric center of the lens is nothing but called as pole. And the distance from the center, so this is denoted by C. So the C1 and C2. Okay, because two spheres has centers, so one sphere is denoted as C1 and another as C2. And the distance from center to the curved surface, either it may be here or it may be here. Is it clear? So this distance is nothing but denoted as R1, and the distance between C2 and curved surface is nothing but called as R2. That means the distance from the center of the sphere to the curved surface is nothing but called as radius of curvature, and here the distance from the center to the curved surface is nothing but called as radius of curvature. As we have two centers, we also have two radius of curvatures, and the line joining the centers C1 and C2 passing through pole is nothing but called as principal axis. Clear everyone? That means the line which is passing through both the centers and passing through pole is nothing but called as principal axis. These are the terminologies we use for the lenses. Now we will learn about focus of a lens. So now we will consider a convex lens, that is biconvex lens. Is it clear? Now this is a convex lens. So already we have learned the terminology, that is this lens will have two centers. Why? Because these two surfaces are the parts of two spheres. So it will have two centers. So consider this as C1 and this as C2. Okay. So and the line passing through C1 and C2 is nothing but called as a principal axis. And the midpoint of the lens, that means the midpoint of this lens is nothing but called as optic center, and it is represented by P. Okay. Now for finding the focus of a lens, so generally we will see if a ray parallel to principal axis has hit the convex lens. So what happens? Refraction has to take place. So here generally first see how many times refraction take place. How many times the ray is changing the medium. So suppose this is a so it is a one medium and this lens is a glass. So here it is a medium. So this incident ray is changing from air to glass. So here one change of medium has taken place, and again this refracted ray comes out from the glass into the air. Is it clear? That means here another change has taken place. That means two times the medium is changing. That means the ray is changing the medium two times. So refraction also occurs two times. So what is the definition of refraction? Bending of light ray from one medium to another medium. That means bending of light ray when it is changing from one medium to another medium. So now here refraction takes place when it is changing from air to glass. So one time refraction takes place, and another time when the ray is moving from glass to air. Here also one time of refraction is taking place. So two times the refraction is taking place. So now how this ray will be refracted we will see. So now if you consider like this, you will be getting confused. Now I will consider only one part and I will make you clear. Okay. Now see, this is a part. This is C1 and this is C2. So this is a ray incident on the convex lens. See now here the ray is traveling from, so this is air and this is glass. Okay. So this is rarer medium and this is denser medium. How you can say that this is a rarer medium and this is a denser medium? By values of refractive indices. Okay. Now at this point, see now when the ray is entering from rarer medium to denser medium, what happens? The ray should bend towards the normal. At this point I need to draw a normal. So how to draw a normal? For simplification, how we will draw a normal? We will draw a normal from the center. Okay. But here see, I have two centers. Okay. Now from where I Okay, make that part a sphere. So generally center will be on the sphere. So where the sphere is? On this side. So center for this sphere will be this point. Okay. So for this surface, that means for surface 1, the center is C2. Okay. Now the ray which is at this point. So now draw a normal at this point. So at this point the normal will be this one which is passing through center. So this is the normal. So if you consider this as a plane medium. So what happens? This light ray which is incident at this point, it will travel in the straight. So that means this is the original path. That means without any deviation it will travel. Okay. But here I am considering it as a lens. So when a ray is traveling from rarer medium to denser medium, what happens? The ray has to bend towards the normal. That means this is the original path. So what happens? This ray will bend towards the normal. That means this ray, what happens? It will bend towards the normal. Clear everyone? So now here this ray will bend towards the normal. Clear till here? Now here we will consider the second surface. Okay. Now this is the second surface. And here it is C1, here it is C2, and the ray has been incident at this point. Okay. Now here also same condition. So now here this ray is entering from denser medium to rarer medium. That means here it is moving from glass to air. That means denser medium to rarer medium. So what happens when a ray is moving from denser medium to rarer medium? The ray should bend away from the normal. That means when a ray is entering from denser medium to rarer medium, the ray bends away from the normal. So now at this point, how to draw a normal? Is it clear? Simple. Consider the part as a sphere. So this part, center is nothing but called as a center of this part. That means for surface 2, the center will be C1. Okay. Now I am drawing a normal at this point. So how to draw a normal at this point? This is the normal at this point. Okay. So if we consider this as a plane surface, what happens? This ray travels in the straight path. Okay. So this will be the original path. Okay. So what we are saying here? When it is traveling from denser medium to rarer medium, the ray should bend away from the normal. That means if this is the normal, okay, if this is the normal, okay, this should travel away from the normal. That means this original path will travel away from the normal. That means at this point it will travel like this. Is it clear? So when it is traveling, it is meeting the principal axis at this